G'day guys, today we're going to do an applications of calculus question that asks us to suppose that a person's body surface area A is related to the person's weight according to the rule A equals kW to the 0.4 for some constant K. Use differentiation to find the approximate percentage gain in A when W increases by 2%. Now we can use the language of calculus to express percentage changes, especially like these incremental percentage changes. And the way we do this is we're going to say that the change in W, or dW, over its original amount, or just W, is going to be equal to, as a decimal, 0.02. And what we're looking for in this question is the approximate percentage gain in A. So we're looking for dA over the original amount of A is the purpose of this question. Now what we're going to do, guys, is we're going to first of all differentiate the rule, and then we're going to try and rearrange it, so to speak, and try and produce this particular relationship here. So let's get to it. If we're going to differentiate A, we're going to start with dA. We're going to start with dA over dW, which is equal to, we take the 0.4 to the front, so it'll be 4 over 10 or 2 over 5 times K, because that's just a constant, W to the power of 0.4 take 1, or negative 0.6. Cool. So we're going to rearrange this a little bit to make our algebra a little bit easier later on in the question. We're going to say that this is equal to, guys, I'm going to keep the K in the numerator and I'm going to take the W to the denominator. And I have 2K over 5W to the power of 0.6. Great. Now that's what dA dW is equal to. So what I'm going to do, guys, is... So what I can do with this, guys, is I'm going to multiply both sides by dW. And on the left-hand side, the dW's will cancel out. And on the right-hand side, we are left with this expression. So let's just rewrite that. Great. Now what I'm going to do now is I'm going to divide both sides by A. And the reason I'm going to do that is because if I do that, I now, on the left-hand side, have the expression that I'm looking for in the question. So now I have dA over A, or the percentage change in the body's surface area, is equal to this expression. Now what we have to be able to do here is we have to be able to relate this somehow to the change, or the percentage change in the person's weight. So what we're going to do is substitute in what we know A is equal to, which we get from the question up here. A is equal to kW to the power of 0.4. So I'm going to have dW at the top, and in the denominator, rather than having A, I'm going to have kW to the power of 0.4. Cool. Now what I can do is I know that if I multiply these two fractions together, the k's will cancel out, and the w's, I can add the powers in the denominator. So 0.6 plus 0.4 is just going to be 1, or w. So what I'm left with is 2 over 5 multiplied by dW over W. Now guys, I'm well aware of what dW over W is equal to, so what I can do is I can say Therefore, the percentage change in area, or dA over A, is going to be equal to 2 over 5 times by 0.02, which is equal to 0.008 or 0.8%. Great. So guys, let's just go through what we've done here. What I started with is I wrote down what each of the variables that I'd been given. I'd been given the percentage change in the person's weight being 2%. They were asking me to look for the percentage change in the body surface area. What I did is I first differentiated the area of the person's body with respect to their weight. And then what I did is I used a couple of steps of algebra to manipulate the derivative expression so I could come out with dA over A in terms of dW over W. So my unknown percentage change in terms of my known percentage change. And then all I have to do is from there, I'm simply plugging in the value that I had for this one. And then it's a bit of multiplication and we come out with our answer. So guys, I hope this video helped. If it did, give it a thumbs up. Subscribe to my channel if you'd like. I put out new videos all the time. And if you have any questions regarding this problem or other calculus problems, be sure to leave them in the comments section below. I'm always looking for new video ideas, and the more I can get, the better. So having said that, these kind of questions, guys, if you don't get it straight away, re-watch the video. There are many videos on my channel of particular questions like this. But when it all comes down to it, you can watch as many videos as you like. You've got to start trying to nut out the problems. And you know, as I say in a lot of my videos, you've got to keep bashing your head against the wall until the wall eventually falls down. So I hope this video helped again, guys, and I will see you soon. But again, most of all, enjoy your maths.